Good afternoon, everybody. This is a live update as we have a convective line with a severe thunderstorm warning that is approaching the border of Vermont. We just had a new severe thunderstorm warning that was also issued here. This severe thunderstorm warning includes Whitehall, New York. There is the Vermont-New York border. Soon that severe thunderstorm warning is going to be extended east, and it's going to include the Rutland area as well. As we expected, there are some embedded circulations within this line because of that strong low-level jet just out ahead of it. One of those embedded supercell structures is closing in on the Argyle area, and that storm also has a severe thunderstorm warning. I did include my initial target area up off to the upper left as this convective line is beginning to approach the target area there in southern Vermont. That was where I was probably going to target. My virtual target would have been southern Vermont there. Secondary target down into northeastern Pennsylvania. That secondary target really fluffed out. And I'm a little bit concerned about this storm in the Argyle area here. We're using Burlington, Vermont radar. This is to the south of the Kingsbury area. Believe it or not, I've actually storm chased quite a bit in this region when I was living in New York City, trying the marriage experiment out there, and I actually did get a chance to chase a lot of these alleys across the Northeast, and this is one of them here. Eastern New York, Glens Falls into southern Vermont, down into western Massachusetts, as well as kind of the severe thunderstorm alley up here in the Northeast, down into northwestern Connecticut, even central Connecticut as well. Gets hammered. Southeastern New York there. Another little tornado alley, south central into southeastern Pennsylvania too. Some surprisingly decent terrain out there to the west of Harrisburg, along those hills as well. But of course, a drone comes incredibly handy out there. So this one right here, and I would probably put a tornado possible deal on there, but it is mainly damaging straight line winds. The gust front probably is preceding it just a little bit, so it is going to be difficult for these to wrap up, but there is an accelerating low-level jet out ahead of it, and you can actually see some of these mesocyclones with weaker convection off to the northeast. That is to the southwest of Montpelier, Vermont out here. Pretty weak convection, though, up there to the northeast. Those are definitely not mesocyclones. But then you kind of get down to this QLCS type of a pattern, quasi-linear convective system out here. This is a little transient supercell structure just to the south of Ticonderoga. You got another one just to the south of Dresden. Has a little bit of a hook-like feature trying to pull in a bit of inflow. This one has a pretty long RFD feature, some pretty strong westerlies within that RFD. It is possible that it could pull in a little bit of inflow on the north side of that RFD on the cyclonic curvature side. Let me make sure that I am going live here, folks. I might have accidentally not hit the button again. I'm getting used to using this different computer, different streaming setup. And yep, that's exactly what happened. I did not go live. Let me press the button here real quick. And there we are. We are live. Sorry about that, everybody. I began this live stream and was actually going for about 5 or 10 minutes before I realized that I failed to press the live button. But here we are. We have this convective line that is approaching Vermont, the western border of Vermont. Yes, we are talking about Vermont severe weather today. And we do have this QLCS type of a pattern that is approaching the western border of Vermont to the west of Rutland area, that area that got hammered so bad by flash floods from Hurricane Irene, which is one of about 15 or 20 intercores of hurricanes that I've intercepted here in the U.S., but bad flooding caused by Irene. We got it down in the Outer Banks of North Carolina, and then it went all the way into New England and dumped crazy rain out there across Vermont. Big-time flash floods out there. So these are the storms that I'm watching right now. There are some embedded supercell structures up here. This one, just to the in the Ticonderoga area, you do have kind of an elongated RFD feature there that is approaching the Orwell, Vermont area. Could be some stronger westerly winds associated with that RFD. Maybe it could pull in some inflow as well on the north side of that RFD. And we have another embedded supercell structure down here to the south of the Dresden area. And I'm also watching this more isolated storm very closely down near the Argyle area. This one has a little bit more space between it and the storms off to the south. So I do think that if any storm does have a tornado potential, it is this one near Argyle. Kind of has that classic bean shape. It is still a little bit far away from that radar. That scans relatively high because of the mountainous terrain out there. So we are scanning pretty high up inside this storm. And I'm not seeing much in the way of a mesocyclone just yet with this storm, but I know that it's there. It's likely exists below the radar. We can kind of see hints of where that mesocyclone would be located just to the south side of Argyle there. Probably have a really big mega shelf with that circulation back behind the shelf cloud a little bit. Might even be a bit wrapped in rain out there. Certainly some strong damaging winds that are associated with that. And echotops are also a great way to assess the relative dominance of a storm. And look at that echotop right there with that storm. It is pretty tilted with the top of the cumulonimbus tower being to the north of Argyle, whereas that circulation is off to the south. So it does seem to be tilted unless that's a left split that's getting peeled off on the north side. If that were the case, then we'll be watching this region here for some enhanced echotops. But you can see off to the north, those other severe warning storms just don't have the same echotops as that one does off to the south. So that one's likely tapping into some pretty substantial instability. The ones off to the north are lower topped convection, not as healthy, but then you get that big echotop right there. That's spiking up to about 50,000 feet. So that's a very mature, likely a supercell storm. When the updraft of these storms start to rotate, then it enhances the updraft speed within the storm. And it does look like that echotop is associated with this portion of the reflectivity. So you likely have kind of this elongated RFD or flanking line type of a feature extending off to the southeast. And likely that mesocyclone is kind of associated with the comma head of this miniature bow echo there that has just gone through Argyle, possibly with some damaging winds there in the Argyle area. And this is going to continue moving off to the east, eventually toward Rupert as well. Mount Holly downstream, Paulette, Dorset area out here. Looks like this storm is going to pass the more severe portion of the storm, should pass just to the north of Manchester, Vermont out there, but figured I'd break down this Vermont severe weather. Let's take a look at the environment too and see exactly why these storms are behaving like this. We do know that the kinematics are going to eject off to the northeast of northeastern Pennsylvania toward Vermont. So I expect that the kinematics and those wind fields are quite favorable across Vermont, but it is likely that the thermodynamics didn't quite come together up there. You do have a couple severe storms as well just to the southwest of Albany. But let's take a look at northeastern PA. This was going to be one of our secondary target areas. Scranton, you have a pretty strong storm moving through your area right now. Kind of a conglomeration of about 3 to 4 little supercell structures. Probably could issue a severe thunderstorm warning with this one, considering there's such strong winds just above the ground getting mixed down to the surface. A little bit of some convergence along that boundary to the south of Scranton. Some of these could also develop a mesocyclone, so we'll have to keep an eye on some of these storms within this convective line that is extending from Scranton and off to the south. But really this little area of convergence, you can see these little mesocyclones that are forming. Looks like a couple of them, maybe also one just on the northeast side of Scranton there. Little supercell structures. Let's take a look at echotops and see just how that rotation is enhancing the updrafts. And not too much in terms of echotops. In fact, I'm not seeing very much in the way of dominant storms here down in the Pennsylvania target, which is good news. You guys have had enough severe weather up there. But then, southwest side of Albany, you do have slightly better echotops with that convection. But really, nothing compares to this big blob to the north of Argyle. Does have a severe thunderstorm warning. Waiting for this thing to start to rotate. Maybe that comma head might generate just enough rotation to get a tornado warning, but I'm not seeing it right now. basically just some strong, damaging straight line winds well off to the southeast of Argyle there. A couple little pops in there, but watching for mesocyclone formation here to the northeast of Argyle, south of Hartford, Vermont, but just not seeing it right now. So let's take a look at the environment and see why the storms are behaving the way that they are and why the southern one is a bit of a nothing burger. Take a look at some of those surface maps. I suspect that there's a lot of cloud cover around Vermont, and we just didn't quite have the breaks in the clouds to generate that surface-based instability. Those low-level lapse rates, those elevated mix layers are incredibly important to generate big severe weather, especially in the eastern U.S. Basically, when you bring elements of Great Plains outbreaks to the eastern U.S., that's when you get those big severe weather outbreaks across the eastern U.S., and that includes having a stout elevated mix layer. I think we got a severe thunderstorm watch. Let's see, not even a severe thunderstorm watch was issued. They did have a 5% tornado. There is a mesoscale discussion. Isolated damaging wind gusts possible in Vermont. And looking at those temperatures, they are in the low to middle 70s in Vermont. Dew points 60 to 62. Definitely didn't hit that 65 up there in Manchester, for sure. But here is that mesoscale discussion for the state of Vermont. Not expecting widespread enough severe weather. And it looks like the dew points really decent dew points across eastern Pennsylvania, but those surface temperatures are quite low. Back into the upper 70s there across the target area of northeastern Pennsylvania, and that's where that strongest wind shear was supposed to be located. There you can see that convective line along the front, well ahead of the actual front and the wind shift. So this is definitely a weakening front with time, but it is surging off to the east-southeast. I'm a little bit slow with this new style of mouse pad on these Dell computers. Oh yeah, there it is. So there you can see the problem in Vermont. The instability just didn't quite make it there. It went through western Massachusetts into the far southern tip of Vermont. You have these nicely back surface winds too, south-southeast surface winds. But I suspect that the very best wind shear is likely over Vermont, where you have a lot of convective inhibition. Hardly any cape up there because of that cloud cover holding in. There was a lot of dry air here across northern New England, and anytime you get big moisture advection like this with a strong low-level jet, it's going to be associated with cloud cover. When you're bringing this moisture into a relatively dry environment, it's just going to create widespread cloud cover, condensation out there. Even northeastern Pennsylvania socked in those clouds, a relatively weak front. However, those storms to the south of Scranton look like they're moving into a nose of about 2,000 joules per kilogram surface-based cape, and that's nosing up into those storms near the Albany area. But definitely Cape way underperformed across eastern Pennsylvania. That was a secondary target. And really those Cape values of 2,000 to 3,000 back into northeastern Pennsylvania are what made that secondary target most appetizing. And it was the kinematics in Vermont with sufficient low surface-based instability developing. That didn't quite happen either. And the wind shear definitely ejected more rapidly out of northeastern Pennsylvania. And right now it is located over southern Vermont, western Massachusetts, southwestern New Hampshire. That's the area that I would watch for maybe an isolated tornado, or at least a few more damaging wind gusts up there. But overall, this severe weather setup definitely looks like more of a nothing burger for northern New England. And look at that wind shear eject east of the convective line, kind of weakening as it approaches New Hampshire up there. Moving out of that instability. Zero instability in New Hampshire and really very little instability across Vermont. But it is possible that in southern Vermont, western Massachusetts, southeastern New York, that mode that right now is trying to mature to the south of Albany. That certainly does have a chance as well. But this is how it goes in the Northeast. This is why I've lived in the Great Plains my whole entire life. Sometimes, though, it can go big, especially with those tropical systems that will move off to the Northeast. They can bring big flooding. They bring a powerful surface low, bring the low-level shear to the eastern U.S. And the tropical systems are probably the most common way to get tornado outbreaks over the Northeast. And that's exactly what happened over portions of eastern Pennsylvania and New Jersey, central and northern New Jersey. So this storm to the south of Hartford, Vermont, this is the one that we've been watching pretty closely. This one looks like it's trying to pull in a little bit of inflow near the Goose Island area. You kind of have this elongated appendage. Sometimes you can get kind of a large area of convergence along those, and then they'll start to pull in some inflow, and then you'll start to get some cyclonic curvature in that hook-like appendage. As the mesocyclone will intensify above it, it can then stretch that rotation, tightening it up. So West Hebron and East Hebron, keep an eye on this storm. It doesn't have incredible rotation right now, but I could see some enhanced damaging wind possible too, and I'm really not seeing any rotation with that storm, at least on Albany radar. Are you supposed to say it Albany? We can shift to Burlington, which is a little bit further away, scan higher up in that storm, and then we can sample that mesocyclone that's trying to form, and you can actually see a little bit of inflow coming in here with the brighter green colors to the north of Salem, Vermont. I think that's Vermont. It actually might have, yep. Now it might be about to cross into Vermont. This is the border right there, so that's still Salem, New York. But it does seem to be increasing its inflow a little bit to the north of Salem. There you can see that mesocyclone even getting a little bit more robust on the latest scan. I don't think that it'll produce a tornado, but maybe near Rupert. That's in kind of southwestern Vermont. That most of that instability, according to the RAP analysis, was just barely nosing in to southern Vermont here. So it is possible that this storm is a candidate to become surface-based, tap into that greater wind shear. We also have about 200 0 to 1 kilometer storm relative helicity over southern Vermont into western Massachusetts. So I do think that that storm has a chance to wrap up and maybe even produce an isolated noodle. Definitely has a supercell structure, especially when you're using Burlington, Vermont radar, scanning up a little bit higher in the storm. Starting to get a little bit of that sickle shape appearance, a little bit of cyclonic curvature to the reflectivity pattern. And we'll just have to see if it can turn right. If that mesocyclone can mature a little bit, then that'll force a more easterly storm motion, squeeze out even more low-level wind shear out of that, a stronger low-level mesocyclone, and it might even be capable of drilling through that shallow stable layer right near the surface. Allergies are kind of getting bad. I just ran 6 miles out there. Little smoky outside here in Colorado, believe it or not. Just a little bit smoky. And then you can kind of see a more linear configuration extending off to the south of that, to the east of Malta, down to our Clifton Park. And then we also have that sub-severe mode to the southwest of Albany. I don't think any of these are going to make it. And a lot of these renegades, little renegades that have tried to develop out ahead of the squall line, have not been able to survive. Just not enough cape. The elevated mix layer is kind of moving parallel to that cold front instead of surging east and overspreading across the warm sector, clearing out those clouds, leading to surface heating in Big Cape. So right now, the only severe thunderstorm warning is this storm to the west of Rupert, Vermont. And it could develop some tornado potential, but mainly damaging winds are going to be the main threat with this storm. And it does look like that forward flank gust front is getting a little bit tighter. That gradient right there, the tighter that gradient is, the better chance that this will have of producing a tornado. Watching this southern area for a little bit of an RFD surge as well. down in that portion of the storm. So, thermodynamically, this setup definitely fell short of what it was supposed to be. There is decent wind shear out there. I'd say the HRRR low-level jet magnitude of about 30 to 40 knots has definitely verified a little bit more so than the 3-kilometer NAM. But you really just didn't get that surface-based instability far enough north to where the favorable kinematics are located. The exception being, though, down there in far southern Vermont, you've got about 200 0 to 1 kilometer storm relative helicity, some non-zero CAPE of about 1,000, 1,200, some surface-based instability. So it is possible that that storm that we are tracking right now could develop some non-zero tornado potential. But I would say that the HRRR instability verified a lot more so than the 3-kilometer NAM. Definitely mixed out some of those dew points. Probably calibrated for more of an East Coast type of a severe weather situation. Here you can see that loop. And the instability did make it up to southern Vermont, but then the front choked it off. So it did make up into central and northern Vermont, where even more favorable kinematics are located. So thank you, everybody, for tuning in to my weather report. Figured out to follow up on my morning one as the severe weather is playing out. A little bit different than I thought it was going to. Let's take a look one more time at the storm relative velocity here. See what kind of mesocyclone this thing may have. And there you have it. Definitely not a good low-level mesocyclone. But if we use Burlington radar, which is way up there north, the dew points were about 3 degrees lower than the 3-kilometer NAM was showing. And scanning up higher up into the storm, you can see kind of this weak, broad mesocyclone closing in on the Rupert, Vermont area. And also this one now up near Middletown Springs, starting to be a little bit of a QLCS pattern, moving into that favorable wind shear. We may get a tornado warning or two tonight, but it's not looking likely. Thermodynamics definitely fell short. But you can see this little sickle shape. That's a little embedded supercell storm. This is a little embedded supercell storm. This is the dominant supercell storm closing in on Rupert. And that is the only one that is severe warned right now as well. So thank you, everybody, for tuning in to this weather report. Hope you enjoy my weather reports. My vehicle actually goes into the shop tomorrow at 11 a.m., so I'm going to get some of the damages fixed from Hurricane Ida. Mainly the exhaust header is getting fixed tomorrow. I'm still driving with the donut tire right now, and you may have seen that I got featured on Colorado's, not sure if I'm allowed to swear, but SHITTIEST 3.0. So I just shared that on Facebook, and quite an honor to be shared amongst that site of beater vehicles. Showing Dominator 4 driving through to get some coffee this morning out in Evergreen. And this line down from Mechanicville through Greenwich up all the way through Rupert is starting to get interesting. This one to the west of Rupert, probably moving north of the instability, starting to die out a bit, but still has that severe thunderstorm warning. And we do have a new severe thunderstorm warning off to the south. So these storms could be interesting down near Mechanicville. We're using Burlington radar, so we are scanning a little higher up in the storm, kind of showing how healthy some of these cores are, reflectivity patterns, some heavy rain, a little bit of a QLCS pattern, kind of a wavy look to that squall line, maybe a little supercell up near Schuylerville. And there you can see our mesocyclone closing in on the Rupert area. We're skidding way too high up into the storm for those southern ones that just got severe warmed. But let's go down to Albany, and take a look at, see if this thing is rotating. I'm not seeing much in the way of rotation. Some stronger wind gusts, though, just behind that shelf cloud. Mechanicville could get some decent winds, maybe gusting to 60 miles an hour. Stillwater, not Stillwater, Oklahoma, but Stillwater, New York. Down there. These have a chance of being surface-based storms. So looking at the RAP analysis, there is ample surface-based instability, even up into the Green Mountain National Forest. So these storms do have a chance to maintain severe characteristics from Rupert. That storm up near Rupert seems to be dying a bit. So I do think that that's running into that low-level stable air. But these from Greenwich, north of Greenwich, west of Easton, down near Mechanicsville, I do think that these have a chance to intensify or at least maintain severe thunderstorm strength as they head towards southwestern Vermont. But overall, it definitely is a bit of a nothing burger. In general, you kind of have this slight bowing out of the convection, but most of the instability, Manchester and off to the south. So I'll keep monitoring this severe weather event through the evening, and if there are any tornado warnings, I will be going live, or at least I'll be make sure to post them. I'm probably going to cook a steak tonight. I feel like I need some iron, some red meat. So thank you, everybody. Never stop chasing.